with this data set. In this video, I am going to show you how to compare two independent masses. You are going to compare two independent groups. I have in here the nitrogen mass that was obtained from the composition of organic matter, and in here I have the nitrogen mass that was obtained from the air. You have to compare two independent groups. You have this group and you have this group. How could I compare these groups? Well, you can do it in Microsoft Excel, but we have the commander that is a package for statistical analysis, and I like very much this package. I have opened my RStudio, and I can open Commander just typing this command and press enter. I already have opened it, and it's in here. Well, the first thing that I have to do is to import my data set to Commander. Well, I like very much this package because when I began to work with him, I have always used spreadsheets. For to be more clear, I always have been using the Microsoft Excel. So all my data sets was in spreadsheets, and my spreadsheets Microsoft Excel. The commander can open these spreadsheets. I can just go to data, import data from Excel file. I let this row unchecked because my samples don't have names. I go to OK, and I go to spreadsheet 1. I go to here. I go to open, and my data set will be imported to Commander. I can click in here, view my data sets, and I can see my data sets right in here. Now I want to compare these two independent groups. How could I do that? Well, you could do statistical tests, but you can also do it visually. For example, I want to compare these two masses. I want to compare these two groups. I can go to groups, plot of the mass, and I will plot these two groups. I can go to options, and I can show the error bars in here. I can use standard errors, standard deviation, confidence levels. I like to use confidence intervals. So I go to OK, and I can see my plot of emissions. Here I have the nitrogen mass obtained from the air, and then here I have the nitrogen mass obtained for the chemical decomposition of organic matter. You might see that both groups have close average values, but these groups have a very small standard deviation or confidence intervals. So I have two groups with very close average values, but these two groups obviously are different. I might do it, I can do it so I can do this using box plots. I can go to my commander, and I may go into graphs, and then go into box plots. I go to box plots. I am going to mark group variables, OK, and OK. Now I have the box plots, and I can also see that these two groups are different. I already know that these two groups are different, but I can do it using statistical tests, the hypothesis tests. Normally, when they compare two groups, I can use the Ttest. I'm going to use the Ttest. I'm going to my commander. I go to statistics. But first, I can go to mans, and they can use independent sample t-test. But I must, at this point, I have to say to you that t-test is a parametric test. What this means? What is a parametric test? A parametric test needs normally distribution variables, homogeneity of variances, and you cannot have outlier samples. Well, I can go first to summaries, and I will do a test for normality, a test of normality. Well, I will use the Shapiro-Wilk test. Is one of the most used tests for normality, and I can check in here for C normality in both groups. I go OK, and I'll go to apply. So my data, the Shapiro-Wilk test was opened in Studio Mainframe. He gives me a p-value of a p-value that is higher than 0.05. It is so I can conclude that my data set is normally distributed, and it shows too for ash group. I can see that the nitrogen mass obtained from the air was more normally than the nitrogen mass that was obtained for the chemical decomposition of organic matter. So the Shapiro-Wilk test says me that my data is normally distributed. If I have a p-value lower than 0.05, I can say that my data is not normally distributed. In this case, my data is normally distributed. I can also look for normality for data distribution using plots. It's using this frame. I can go for graphs, and I go to, and I can go to histograms. I go to histograms. I have my options in here. I like to put it in percentages and go to OK. Well, I don't show I don't mark it to show for ash group. So I go again in my commander. I go to graphs, histograms, and I will select groups. And now I go to OK. Well, here you have the distributions. It's quite hard. It's very hard to see that the data is normally distribution when you have a few data points. But you can see it easily when you have more data points. In this case, the histograms will not be very useful. So you have to use the Shapiro-Wilk test. I can look now for the variances. Let me go to Commander, and then we go into Statistics, Variances. Since I have two samples, I could use the Barlett test and Levine's test. But since I have just two groups, I will go to F-test. I'm going to Options. I'm looking for a choose side, and you go to OK. I'm go to Studio. And the F-test to compare the two variances. The F-test had shown to me that I don't have equivalence variances. My variances are not equivalent. The variances are different because I have a p-value much lower than 0.05. So I know that my data might be considered normally distributed, but I don't have equivalent variances. So I will do a t-test. T-test is a parametric test, and I will use this parametric test. Let me go into statistics, mans, independent sample Ttest. You have two independent groups. I'm selecting my groups and I go to options. In here, I have to assume equal variances. I will select no because my variances were not equivalent. I will go to OK, and the results from my Ttest will open in here in the studio. In here, I have the Welsh two-sample Ttest. When you have non-equivalent variances, the Ttest was known as Welsh two-sample Ttest. And I get a p-value much lower than 0.05. This means that my two groups don't have equal variances, equal average values. The two groups are not equivalent. So I have done my Ttest, and the object of this video is to show you how to compare two groups, two independent groups. In the next video, we are going to compare dependent groups.